Hello there, I'm George Everett, your guide and narrator here on Z Science, where curiosity meets calm, and science helps you drift into sleep. I tell quiet stories about space, time, and the strange beauty of the universe, told slowly, softly, and with wonder. Tonight, we'll journey beyond our solar system, into the deep silence between the stars, where light travels for ages, and worlds drift without a sun. Some of what you'll hear might sound like a dream, but every bit of it is real. So lie back, breathe deeply, and let's begin our journey through the sleeping universe. There are planets with temperatures hotter than stars. Stars are known for their fierce heat, glowing with plasma that burns at millions of degrees. But astonishingly, some planets come close. One of them, Kelt 9b, reaches over 70 degrees Fahrenheit, hotter than many red dwarf stars. This gas giant orbits so close to its massive blue sun that it circles once every day. It is tidally locked, one side forever facing its star, absorbing relentless radiation until its atmosphere streams away like a comet's tail. The heat is so intense that molecules split apart and metals turn to vapor. It isn't merely hot, it is extreme beyond comparison. These ultra-hot Jupiters blur the boundary between planet and star. They are blazing, storm-racked infernos that may last only briefly before dissolving into darkness. Some might even be made almost entirely of diamond. It sounds like science fiction, yet under the right cosmic chemistry, it could be true. If a planet forms around a star richer in carbon than oxygen, the materials available can create carbon-rich worlds, planets whose deep interiors might transform under pressure into vast crystalline diamond. One candidate, 55 Conchoree E, is a super-Earth twice our planet's size. Within its crushing depths, carbon may crystallize into enormous regions of diamond. It wouldn't glitter or sparkle as jewelry does. There would be no shine, only darkness, heat, and astonishing density. Still, the thought of a planet forged from carbon mountains, glinting with hidden crystal, feels almost otherworldly and precious. Some exoplanets orbit to suns, like the desert world of Tatooine. In stories, we've long imagined twin sunsets, two stars sinking below a far horizon, and now we know such skies exist. These circumventory planets travel graceful, complex loops around paired suns that orbit one another. When the stars are close, the planet circles them both as if they were one. When farther apart, it may orbit one star while the other tugs and tilts it from afar. The result is a world with shifting light cycles, changing seasons, and double shadows. Rare and delicate, but real, such systems give some distant worlds to dawns and to dusks. A vision once born of fiction, now proven by science. There are planets where it rains molten glass. Imagine a world so alien that even its weather defies imagination. HD 189,733b, a gas giant larger than Jupiter, orbits. So near its star that a full year lasts barely 2 days. Its skies shimmer a deep, hazy blue, yet the atmosphere seethes at 1700 degrees Fahrenheit. With winds racing thousands of miles per hour. Tiny grains of silicate, the building blocks of glass, fill the air. When they condense, they fall as glass rain, swept sideways by roaring winds. From afar the planet glows a calm azure, but up close it is a storm furnace, beautiful, violent, utterly uninhabitable. It reminds us that nature's imagination outpaces our own. Other planets may be wrapped in oceans thousands of miles deep. These ocean worlds could be covered entirely by water. No land, no continents, only endless sea. Unlike Earth's relatively shallow oceans, their waters might reach hundreds or thousands of miles down. At the surface, waves might roll beneath muted skies, while far below, pressure would rise until water transforms into exotic high-pressure ice, dense and solid under crushing weight. A rocky core may rest deep within, hidden beneath the dark waters. Some of these worlds may hold internal warmth, keeping liquid layers alive beneath the ice. Could life exist in such places? No one knows. But many scientists suspect ocean worlds may be far more common than we once believed. Gentle, glistening planets turning silently in the dark. Far from any familiar sun, some planets are tidally locked, one side always facing their star. Unlike Earth, which spins freely, these worlds show only one face to the light. The day side burns in endless noon, while the night side lies in permanent shadow. Between them is a narrow twilight band where light is soft and temperature mild, a fragile zone of balance. Some scientists think life could survive there, living forever at the edge between day and night. Such planets have fierce winds, strange clouds, and extreme contrasts. Yet they remind us that even in extremes, equilibrium can emerge, and perhaps even life. Hot Jupiters skim so close to their suns that their atmospheres boil away. Imagine Jupiter itself moved inward until a year lasts only days and the heat rises above 2000. Their upper atmospheres blow off into space, trailing like glowing comets. Many of these giants were among the first exoplanets, discovered because their immense size and tight orbits make them easiest to detect. But how they arrived so near their stars remains a mystery. Were they born there, or slowly drawn inward by gravity's hand? Whatever the path, they are unstable, dramatic, and short-lived brief flashes of planetary fire circling faraway suns. Some exoplanets are darker than charcoal. Not every planet reflects starlight like Earth. One world, Tres to be, reflects less than 1% of the light that touches it. It absorbs nearly everything, darker than paint, darker even than coal. Scientists aren't sure why. Perhaps vaporized metals or unknown chemicals veil its upper layers. Whatever the cause, it's astonishing. A planet glowing only faintly with its own heat, almost invisible against the glare of its star. If you could look toward it, you'd see little more than a silhouette, a perfect shadow orbiting in silence, drinking in the light of the universe. We have also found planets drifting alone, unbound by any sun. Most planets orbit stars, yet some are wanderers, rogue worlds set adrift through interstellar space. They may have been born around stars and ejected by gravitational chaos, or they might have formed alone, too small to ignite as stars themselves. Cold, dark, and nearly invisible, they reveal themselves only through faint heat signatures in infrared light. Some may still hold internal warmth, enough to keep hidden oceans liquid beneath frozen shells. Others are completely solid and still, drifting forever through the black. A planet with no sunrise, no sky, and yet the quiet question lingers. Could something live even there in that endless night? Some worlds may have ruby and sapphire clouds. When we picture clouds, we think of water vapor, soft and pale. But on certain exoplanets, the skies could shimmer with minerals. On scorching gas giants where temperatures rise above 2000, elements like aluminum oxide and titanium can vaporize, drift high into the atmosphere, and condense again as mineral clouds, the same compounds that make rubies and sapphires on Earth. These skies might glow red, purple, or deep blue, lit by blazing suns and storms of liquid gems swirling overhead. On one such planet, WASP 17b, scientists have found hints of high-altitude mineral clouds sweeping through its skies. It's almost impossible to imagine a storm of molten jewels in an atmosphere of fire, yet nature makes it real. The universe is stranger, more beautiful, and more inventive than we can ever fully picture. There are super-Earths that could be even more habitable than our own. Super-Earths are rocky planets larger than Earth but smaller than Neptune. They may have stronger gravity, thicker air, and climates more stable than ours. Some could hold deep oceans, calm weather, and long-lasting atmospheres. One promising world, Kepler 442b, lies in its star's habitable zone, not too hot, not too cold, just the right distance for liquid water. With enough mass to hold onto its air, such a planet might offer steadier conditions for life to take root and endure. We don't yet know if it's truly habitable, but these discoveries remind us, Earth may not be perfect, only familiar. There may be gentler homes waiting among the stars. We've found planets that race around their stars in only a few hours. Earth takes 1 year to orbit the Sun. Mercury, our fastest planet, takes 88 days. But some exoplanets finish a full orbit in mere hours. Kepler 78b, slightly larger than Earth, circles its star every 8.5 hours. Its surface glows with molten rock at several thousand degrees. These ultra-short period planets are tidally locked, their stars looming huge in the sky while gravity stretches and strains their structure. They are worlds of fire and speed, fleeting sparks that skim the edges of their stars. Before vanishing into light. Other planets take centuries to complete a single loop. Gupicium, a massive gas giant, needs roughly 1,000 years to orbit its sun. So far away that gravity barely holds it, it drifts on a long, cold path, its light faint and its seasons measured in lifetimes. We can't wait 1,000 years to watch it circle once, but by studying its curved motion, we glimpse the enormity of its orbit. These long-period planets move slowly, gracefully, tracing centuries in silence. Their worlds change, not in years, but in generations. In their skies, time itself seems to flow differently, a slow, patient rhythm beyond our comprehension. We have discovered thousands of planets beyond our solar system. For most of human history, we knew only our own. Then, in the 1990s, everything changed with the first confirmed exoplanet discoveries. Since then, telescopes like Kepler and TESS have revealed thousands more, worlds small and large, fiery and frozen, close and distant. Some orbit in days. Others wander for centuries. Each one reshapes our understanding of what's possible, and we're still just at the beginning. There may be hundreds of billions of planets in our galaxy alone, more worlds than stars, each quietly circling in the dark, waiting to be found. We've detected planets by watching the shadows they cast. When a planet passes in front of its star, even briefly, the light dims just a little. That small dip, sometimes less than 1%, reveals the planet's presence. This technique, the transit method, has discovered thousands of worlds. From these faint shadows, scientists can learn a planet's size, orbit, and even hints of its atmosphere. We are watching distant suns blink ever so slightly and, in those soft flickers, uncovering entire new worlds. Other planets reveal themselves through the subtle wobble of their stars. When a planet orbits a star, gravity pulls on both. The star, though massive, moves ever so slightly, swaying back and forth. That motion changes the color of its light in a rhythmic pattern we can measure with spectroscopy. This radial velocity method was how the first exoplanets were found. It works best for giant worlds close to their stars, but it also reveals distant companions and multi-planet systems. We don't see the planets directly. We see their stars dance under invisible influence, a silent cosmic duet played in light. Some exoplanets have atmospheres slowly escaping into space. A planet's air is never still. But for some, especially those near their stars, the outer layers heat until they drift away entirely, forming long, glowing tails of hydrogen and helium. Over time, these planets may lose mass, stripped down to their rocky hearts. It's a slow erosion, stars sculpting their worlds molecule by molecule. Even planets, vast and ancient, can fade, their substance carried off on solar winds, until only gravity remains. We've found planets in systems with 3 or more suns. Not all skies have a single sunrise. Some worlds orbit amid multiple stars, tangled systems of 2, 3, or even more suns. Imagine standing on such a planet, one star rising while another sets, shadows stretching in different directions, the sky never truly dark. To survive, these planets must follow delicate, stable paths through a web of gravity. Some circle tightly bound pairs of stars. Others loop far outside the entire cluster. Their light and seasons would be strange, but they exist, proof that even in complexity, order can emerge. Some planets circle the remnants of dead stars. When stars die, they sometimes collapse into white dwarfs or neutron stars, dense, dim remnants of what they once were. Around some of these stellar corpses, planets still orbit. They are survivors of cataclysm, enduring the violent death of their suns. In other cases, they may have formed anew from the ashes, rising from stellar debris into fresh worlds. Their skies are dim and cold, their suns pale and ghostly. But they endure, quiet survivors tracing paths through cosmic graveyards. One planet even orbits its star backwards. Most planets move in the same direction their stars spin, following the flow of the disks that formed them. But WASP-17b defies that rule, orbiting in reverse. Perhaps long ago it collided with another world, or a close encounter tilted its orbit. Now it loops against the spin of its sun, a giant world moving in defiance. It's a reminder that the universe allows chaos as easily as order, that even among the stars, not everything follows the same dance. We've seen signs of clouds on planets, light years away, not by looking at them directly, but by studying starlight as it passes through their air during transit. Different gases absorb and scatter light in unique ways, leaving fingerprints in the spectrum. From those patterns, we can tell what their skies contain: hydrogen, water vapor, or even metallic clouds made of silicate and iron. Some planets appear permanently overcast. Others show changing weather. We can't yet see them, but by reading their starlight, we can imagine their skies glowing, shifting, and alive, far across the dark. Some exoplanets orbit closer to their stars than Mercury does to the Sun. Mercury, already scorched and airless, endures temperatures that would melt lead. Yet some worlds circle their stars even closer, where no planet in our solar system could ever survive. These planets complete orbits in only hours or days. Their surfaces may be molten, their atmospheres torn away by stellar winds. Some are tidally locked, one hemisphere forever blazing in daylight, while the other remains frozen in endless night. Others are so near their stars that gravity stretches them like teardrops. They defy what we once thought possible, existing at the very edge of survival. Yet their closeness makes them some of the easiest to detect. Many of the first exoplanets ever found belonged to this extreme class, short-lived, unstable, and brilliant against their suns. But not all planets huddle close to light. Some drift so far away that sunlight fades to a faint, cold gleam. These distant worlds may take centuries or even millennia to orbit their stars. Their temperatures plunge, and seasons can last for generations. Chemical reactions slow almost to stillness. Yet even there, planets persist, orbiting quietly at the limits of gravity's reach. They may be icy giants wrapped in frozen clouds, or rocky, dim worlds crusted in frost and carbon dust. Some might even harbor hidden heat beneath their surfaces, warmth leapt from formation or created by radioactive decay. Though remote and frigid, these planets remind us that life in the cosmos takes many forms of endurance. There may be worlds with rings, grander than Saturn's. Saturn's delicate bands of ice and dust are beautiful, but other planets may have ring systems thousands of times larger. One candidate, J1407b, appears to have rings stretching more than 200 times wider than Saturn's, vast enough to eclipse its own star. These colossal rings could be made of rock, ice, or the remains of moons that never fully formed. As the planet moves, its rings cast shifting shadows, creating unusual dimming patterns that we can see from Earth. If such a world orbited our sun, its rings would fill the night sky, an enormous halo of light and shadow drifting across the heavens. They remain partly hypothetical, but their possibility hints at the grandeur yet to be revealed. For all we've found, we've only just begun. The first confirmed exoplanet discovery was in 1992, barely a heartbeat ago in cosmic time. Since then, technology has leaped forward. We've detected thousands of worlds, mapped their orbits, and studied their skies. And yet, we've seen only hints of their true nature. We don't know what their surfaces look like, what they smell like, or how their winds might sound. We can't yet say which ones have continents or clouds, which might be calm or violent, or which might be alive. Every new discovery is a door opening into the unknown, and with each step, the picture grows stranger, richer, and more full of wonder. The cosmos is filled with planets, and we have only just knocked on the door. Some planets orbit so close to their stars that they are slowly being vaporized. For these worlds, proximity is destruction. Their stars' radiation tears at their surfaces, heating their atmospheres until they stream away like smoke. Over time, they lose mass, shedding layers until little remains. One such planet, KIC 12,557,548 may be crumbling right now, leaving a dusty trail of debris with each orbit. It's as though we are watching a planet dissolve in slow motion, a reminder that even something as vast as a world can wear away. Beneath relentless light, we have found planets that defy every rule. Some skies shimmer with vaporized metal. Some rocky worlds burn hotter than stars. Others are giant gas spheres colder than deep space. Some have tilted or backward orbits. Others rings so immense they block starlight entirely. A few are denser than iron, others so puffy they could float in water. Each new world forces us to rethink our theories of how planets form, evolve, and endure. Science grows stronger through these exceptions. In the chaos of the universe, order is never absolute. It is the balance between pattern and surprise, the quiet puzzles scattered through space that invite us to wonder. Some exoplanets might be water, world's endless oceans with no land. Picture a planet with no continents, no islands, no coastlines, only water stretching in every direction. These ocean planets could have layers of water hundreds or thousands of miles deep. Pressure below would crush stone into strange new forms and turn water into exotic ices that never melt. Above the surface might be calm and silver, or storm-tossed and dark. If life exists there, it would live in deep, sunless seas where light never reaches, guided only by heat and chemistry. We haven't confirmed one yet, but evidence grows. And if Earth is one type of habitable world, perhaps these hidden oceans are another. We've found planets between worlds, the mini Neptune, not quite rocky like Earth, not fully gaseous like Neptune. They sit in between. These planets likely have solid cores wrapped in thick blankets of gas. Some may hide boiling oceans beneath cloudy skies. Others may lack any surface at all. They're too small to ignite like stars, too large to walk upon, and for a long time, we didn't even know they could exist. Now we suspect they may be the most common kind of planet in the galaxy, small, swollen, and mysterious, filling in the spaces between what we once thought possible. Some planets are puffed up like balloons. They are large but light, vast in diameter yet surprisingly low in mass. WASP 2b, for example, is twice Jupiter's size but only a fraction of its weight. Heat from its nearby star causes its atmosphere to expand, turning it into a giant, delicate world that would float if dropped in water. If only such an ocean could exist. Radiation breaks apart molecules, swelling its air into shimmering haze. These puffy planets challenge our sense of solidity, reminding us that even worlds can be soft and unstable, stretched thin by the light of their stars. There are planets where days last longer than years. On Earth, we spin every 24 hours and orbit the Sun in 365 days. But some exoplanets turn so slowly, or orbit so fast, that a full rotation takes longer than a full year. They complete a lap around their star before finishing a single spin. Usually tidally locked, their day sides burn forever in sunlight while their night sides lie in endless cold. There is no sunrise or sunset, just one fixed face staring into fire and one into shadow. On such worlds, the very meaning of time dissolves. A day without end, a year that passes before a single turn, and some are wrapped in haze so thick that nothing beneath can be seen. Not clear blue skies, but heavy, murky veils of chemistry. Photochemical hazes of methane or hydrocarbons can build up, turning entire planets amber or grey. Saturn's moon Titan shows a hint of what that might look like, a golden fog hiding the surface. On distant exoplanets, ultraviolet light from their stars may trigger even stranger reactions, cloaking them in smog that glows faintly through the dark. We can't see their oceans or lands, only the soft blur of haze, a veil drawn over alien worlds, waiting to be lifted. We've seen evidence of winds howling across entire alien worlds. Weather isn't unique to Earth. On many exoplanets, especially large gas giants, the air moves with astonishing speed, thousands of miles per hour. Some of these worlds are tidally locked, one side forever facing their sun. That contrast in temperature drives fierce winds that race around the planet, redistributing heat from the day side to the night. Astronomers have detected these winds through tiny shifts in starlight, and some blow at up to 5,000 miles per hour, fast enough to cross a continent in under an hour. They carry vaporized metals, shift clouds, and shape the glow of the planet itself. We can't feel these winds, but we can read them in the light, tracing their whisper through the cosmos. Some planets are heated from within. Not all warmth comes from a star. Some exoplanets, especially those in stretched, eccentric orbits, are warmed by tidal forces. As gravity pulls on them unevenly, their interiors flex and stretch, creating friction that becomes heat. This same process keeps Jupiter's moon Io volcanically active, and on some exoplanets, it may melt rock into magma or maintain subsurface oceans beneath ice. These worlds might look cold and distant, but deep inside they pulse with motion and heat. It's energy without sunlight, life without a star, a quiet reminder that warmth can come from within. We've found planets in ancient star systems, almost as old as the universe itself. Some stars formed more than 11 billion years ago, and around a few of them, planets still orbit. One such system, Kepler 444, contains 5 small, rocky worlds. They've been circling their stars since long before Earth existed. Formed when the universe was young and heavy elements were rare, they might be made from very different materials. What might they look like now, worn smooth by eons, their surfaces scarred and silent? We may never know, but their survival reminds us how long planets can last. Enduring through the ages, older even than our sun, and where there are planets, there may also be moons. Yet exomoons, moons orbiting planets beyond our solar system, are elusive. They're small, subtle, and easy to miss. Still, astronomers have spotted hints, faint wobbles in timing, dips in brightness that don't quite match models. One candidate, a possible moon orbiting Kepler 1625b, could be larger than any moon we know. Even smaller moons, if they exist, might shape tides, stabilize climates, or harbor subsurface oceans like Europa or in. We haven't seen them clearly yet, but they're almost certainly out there, circling in the quiet darkness, waiting to be found. Some planets may have entire moon systems of their own. Gas giants like Jupiter and Saturn each have dozens of moons. So imagine a world even larger orbiting a distant star. It could host a whole family of moons, rocky, icy, cratered, or wrapped in vapor. Some might hide oceans beneath shells of ice. Others could have thin atmospheres of their own. If one of those moons orbited within the habitable zone, warmed by tidal energy, it might even support life. Though we haven't confirmed such systems yet, the possibility is breathtaking. Miniature solar systems drifting together, held in quiet harmony. Some exoplanets might support life, but not as we know it. We often imagine alien life as a mirror of Earth, blue skies, water, and warmth. But life could thrive in stranger places. It might live in acidic clouds, under frozen seas, or within thick atmospheres of methane and hydrogen. It might not rely on water or even carbon at all. On Earth, we already see extremophiles that survive in boiling acid, radiation, or darkness. Elsewhere, life could take new forms. Microbial colonies, chemical webs, or slow self-replicating systems that thrive where we never could. We may never meet them face to face, but someday we might detect their faint chemical signatures. Whispers of breath from worlds unseen. There are planets that hover on the edge of becoming stars. Between planet and star lies a grey frontier, the realm of brown dwarfs and superjupiters. These massive bodies may fuse small amounts of deuterium in their cores but never ignite like true stars. One such object, HD 100,546b, glows faintly with its own heat and may straddle that boundary between planet and failed star. Where exactly the line falls is still debated, but these in-between worlds remind us that cosmic categories are fluid. In space, transitions blur, and one thing slowly becomes another. Some planets lie at the edge of their stars' habitable zones. The Goldilocks zone, not too hot, not too cold, sounds simple, but the borders are complex. A planet too far freezes, too close, and its water boils away. Yet on the boundary, a thick atmosphere might trap heat, or bright clouds might reflect it. Seasons could be wild, and life, if it exists, might cling to narrow regions of balance under ice, inside caves, or near volcanic warmth. These edge worlds are fragile and fascinating. Living on the fine line between comfort and chaos, we're learning to read the chemistry of alien skies. With telescopes like the James Webb Space Telescope, we can now study the light filtering through exoplanet atmospheres. Each molecule, water vapor, carbon dioxide, methane, leaves its own spectral fingerprint. By separating light into its colors, scientists can detect those patterns and begin to piece together the air of another world. In some cases, we might even find biosignatures, chemical hints that life is influencing the atmosphere. It's like decoding a message sent across light years, written in starlight itself. On some planets, seasons can last decades or even centuries. Earth's tilt gives us mild seasons, but elsewhere, things can be far more dramatic. A larger tilt or an elongated orbit can create summers that last for decades and winters that span generations. Some worlds may warm intensely as they near their star, then drift into deep frozen sleep. Life, if it exists, would follow this long rhythm, blooming for centuries, then vanishing beneath the cold. Time there flows differently. A single season could hold the story of an entire civilization, and some worlds live forever in twilight, neither bright nor dark, time drifting without dawn or sunset. A world suspended between light and shadow, half dreaming, half awake. We've discovered planets locked in resonance with one another, worlds moving together in perfect rhythm. In some star systems, planets don't simply orbit independently. They follow precise patterns where their paths align in whole number ratios. For every 2 orbits of one planet, another completes 3. This gravitational balance, called orbital resonance, keeps them from colliding and helps stabilize their motion. We see this harmony among Jupiter's moons, and we've also found it far beyond our solar system. Some systems have 3, 4, or even 7 planets locked in resonant chains, each keeping time like instruments in a cosmic symphony. These delicate arrangements can last billions of years, a quiet music written in gravity and motion. Not all signals from distant stars make sense at first. Some exoplanets show puzzling light curves, stars dimming and brightening in irregular patterns. Sometimes, the cause might be clouds, rings, or orbiting debris. In other cases, it could be comets, dust, or even collisions. One famous example, nicknamed Tabby's star, flickered in strange, uneven ways that baffled scientists. Speculation ranged from natural phenomena to vast artificial structures, though no evidence supports that idea. Still, these mysterious signals remind us how much we have yet to learn. Each flicker of light may hide a story we don't yet understand, a quiet question waiting in the dark. Some planets follow orbits so elongated that they nearly escape their stars entirely. Most planets move in neat, circular paths, but some trace long, stretched ellipses, swinging far into the cold before plunging back toward their suns. At their closest, they flare with heat and light. At their farthest, they drift through darkness. These orbits can take centuries to complete. Often, they're the result of ancient collisions or gravitational shoves from nearby stars. A few of these worlds may one day slip free, cast adrift into interstellar space. They are cosmic exiles, barely tethered, their journeys shaped by the delicate edge of gravity's pull. We've even found planets orbiting the remnants of dead suns called white dwarfs. When a star like our Sun exhausts its fuel, it sheds its outer layers and collapses into a small, dense ember. For billions of years, these remnants glow faintly, still radiating warmth. Around some of them, planets continue to orbit, survivors of the star's violent transformation. Others may have formed later, from the debris left behind. These worlds circle dim, pale stars in eternal twilight, their skies lit by ghostly light. They are survivors in the truest sense, proof that even after death, a star can still host life's possibilities. Some planets may have been born from destruction. In young solar systems, collisions are common. Worlds can shatter, moons can crumble, and debris can coalesce into something new. We've seen hints of this in dusty disks with ring-shaped gaps, where shattered material gathers to form fresh planets. These are recycled worlds, built from the remains of others. Their surfaces might still bear scars, their orbits slightly askew, but they exist reminders that creation and ruin often go hand in hand. Even in chaos, gravity rebuilds, shaping loss into something new. There are planets that may have once belonged to other stars. Over the life of the galaxy, stars drift, collide, and exchange companions. A passing star can pull a planet away, capturing it into a new orbit. These interstellar adoptees are rare but possible. Their chemical signatures or tilted orbits may reveal that they were born elsewhere. They are cosmic travelers, immigrants among the stars, living proof that solar systems are not closed worlds, but dynamic, changing families that sometimes trade their children across light years. Some exoplanets may be young versions of what Earth once was. When we study distant worlds, we sometimes glimpse our own planet's early story. These young Earth-like planets may still be shaping continents, forming atmospheres, or erupting with volcanic fury. Their skies may be thick with carbon dioxide or methane, their oceans wild and newly born. Studying them could reveal what our own world looked like billions of years ago, how life began, how air and land emerged from chaos. They are living time capsules, snapshots of creation frozen in the distant light of other suns. We've even seen giant planets orbiting tiny dim stars. At first, it seemed impossible. How could such small stars host such massive worlds? But nature doesn't follow simple rules. In several systems, Jupiter-sized planets orbit stars barely a tenth the size of our Sun. Their orbits are tight, completing in just a few days, their parent stars glowing faintly red. These pairings defy expectation, showing that even modest stars can nurture grand, dramatic worlds. It's a quiet reminder that scale means little to the universe. Big or small, faint or bright planets find their place wherever gravity allows. Some stars have families far larger than ours. While our solar system has 8 planets, other systems may host dozens. Missions like Kepler and TESS have revealed compact systems with 5, 6, even 7 confirmed worlds, orbiting much closer to their stars than Mercury does to the Sun. If you stood on one of those planets, you might see another hanging in the sky, not as a star, but as a shining neighbor. Their orbits are often locked in resonance, spinning together in graceful synchronization. These systems show that planetary families can take countless shapes, tight, balanced, and dazzlingly diverse. Yet some stars host only a single planet. These lonely worlds circle their suns in solitude, with no siblings nearby. Maybe their companions were destroyed or ejected, or maybe they never existed at all. We can't be sure. From their skies, there would be no other planets rising like moons. No gravitational music of nearby worlds. Only one sun and one silent orbit through the dark. It's a stark kind of beauty. A planet alone, keeping faithful company to its star. Some exoplanets may be wrapped in dense, steaming clouds. Imagine a world where the oceans have boiled, the surface hidden beneath thick vapor. The atmosphere becomes a shroud of hot steam, glowing faintly through the haze. These steam worlds orbit close to their stars, where water cannot stay liquid. Inside those foggy depths might be churning pressure, chaos, and heat. A blend of atmosphere and ocean where the sky and surface blur together. We cannot see through the mist, but the thought of such planets half cloud, half sea, adds another kind of wonder to the cosmic sea of worlds. There are places where ice behaves like rock. Under immense pressure, water can form exotic ices, not the fragile kind we know, but dense and solid as stone. These high-pressure ices may lie deep beneath ocean worlds or inside icy super-Earths, creating landscapes of frozen mountains that never melt. Some planets might have entire layers of this crystal ice, hard as granite, beneath oceans still liquid below. It's a reminder that even something as familiar as water can become strange when shaped by gravity's hand. And beyond that, there are worlds coated in ices of ammonia, methane, or nitrogen. In the coldest reaches of space, these gases freeze solid, painting planets in pale blue, pink, or yellow frost. Their surfaces may glitter under distant suns, silent and ancient. Chemistry itself sculpts their landscapes, forming plains, ridges, and frozen seas. These are the still travelers of the galaxy, frozen yet enduring, gliding through time unchanged. We've discovered planets forming inside the crowded nurseries where stars are born. Most stars begin life in dense clusters, busy neighborhoods filled with light, dust, and gravity. For a long time, scientists wondered whether planets could survive in such chaotic places. Would nearby stars strip their material away? Would radiation tear their atmospheres apart before they could even form? Yet against the odds, we've found planets thriving in these stellar cradles. They orbit newborn suns, while hundreds of others blaze around them, their skies filled with more stars than we could ever imagine from Earth. Even in the brightest and most dangerous regions of creation, planets find a way to exist. Some exoplanets were born in environments once thought impossible. When astronomers first began discovering worlds beyond our solar system, they expected order small rocky planets near their stars, gas giants farther away, stable orbits, quiet suns. But the universe had other ideas. We've found planets in binary and trinary systems, planets orbiting pulsars, the collapsed, rapidly spinning remnants of exploded stars, and planets circling faint metal-poor stars, thought too unstable to host them. Again and again, nature proves more inventive than theory. Planet formation, it seems, is not delicate. It is relentless, an opportunist that seizes any scrap of dust and gas, any chance for gravity to pull something new from chaos. We've detected planets around stars that are only a few million years old. Stars live for billions of years, but some already host planets almost as soon as they ignite. These systems are cosmic infants, still wrapped in the clouds from which they were born. Around them, swirling disks of gas and dust sparkle with infrared, like nurseries where new worlds are literally taking shape before our eyes. Some of these baby planets are still glowing with leftover heat. Others are gathering material from the disk, growing heavier every day. They are worlds in progress, unfinished but real, forming beneath the faint warm light of a very young sun. Some planetary systems are older than Earth itself. Our world formed 4.5 billion years ago, yet some exoplanetary systems are more than twice as old, 10 or even 11 billion years in age. Their stars have burned steadily since long before our sun was born. One such system, Kepler 444, hosts 5 small rocky planets still circling after eons. They've survived supernova, galactic collisions, and billions of orbits. These ancient systems are like fossils from the early universe, holding secrets about how planets first began. If life ever arose there, it would be unimaginably old, perhaps billions of years ahead of us. Some planets are giants, with masses measured in tens of Jupiters. They push the limits of what we call a planet at all, too small to ignite as stars, but too massive to be ordinary. They occupy the middle ground, vast globes of gas and heat, glowing faintly from their own pressure. Many orbit far from their suns, their atmospheres thousands of miles thick. Their gravity is immense, their weather systems colossal. A single storm could cover the surface area of Earth. These immense worlds blur the line between planet and brown dwarf, quiet, slow-burning giants moving through space in serene majesty. Some worlds are so dense they could crush iron, while some planets are light and swollen. Others are tightly packed, their matter compressed beyond imagination. We've found rocky worlds twice as dense as Earth, their interiors forced into exotic metallic forms under incredible pressure. On such a planet, gravity would pull harder, the ground beneath your feet feeling unnaturally heavy. The crust might be thick with iron and nickel, their cores vast and solid. These worlds are small but powerful, silent reminders that even among planets, strength comes in many forms. Others are so light they could float in water. These low-density worlds, sometimes called cotton candy planets, are giants in size but whisper light in mass. Their atmospheres are vast and puffy, inflated by heat from nearby stars. Worse, bless. B is one of them. A world so expanded that if you could place it in an enormous ocean, it would float. Their clouds are thin, their air stretched across immense volumes of space. They seem delicate, fragile, held together only by gravity's faint touch. They are planets that breathe light instead of solidity, immense yet ephemeral. Some worlds may have lost their atmospheres long ago. A planet's air is never guaranteed. Over time, stellar winds, impacts, and radiation can strip it away. Small rocky planets close to their stars are especially vulnerable. They may once have been wrapped in thick, protective skies, only to be left bare, exposed rock under endless sunlight. We can see this in their spectral data. The absence of atmospheric absorption lines, a silent void where air once was. These airless planets are like ghosts, remnants of what they once might have been, circling quietly in the dark. But not all planets are fading. Some are still growing, actively gathering mass from their surrounding disks. We've caught glimpses of this process, glowing clumps of material coiling through rings of gas, forming spirals where newborn planets tug on their birth clouds. It's the slow machinery of creation in motion, dust joining dust, rock merging with rock, gravity shaping chaos into order. These protoplanets are warm and bright, their surfaces still molten. They are worlds still being written, gathering their identities one orbit at a time. We have even witnessed the destruction of a planet in real time. Through the lens of the Kepler Space Telescope, astronomers watched a small rocky world dim and flicker, leaving a dusty tail behind it, a sign that it was disintegrating under the heat of its star. In another system, a sudden burst of infrared light revealed what may have been a collision between two planets, a catastrophic impact that vaporized rock and left glowing debris. Creation and destruction are constant companions in the cosmos. Some planets are born before our eyes. Others vanish before we can understand them. Even in silence, the universe keeps reshaping itself. There are planets where metallic snow falls from the sky. On certain scorching worlds, metals like iron or titanium can exist as vapor. High in their atmospheres, those vapors cool, condense, and fall as tiny solid crystals, flakes of metal drifting through hot winds. Some planets may even have aluminum oxide clouds, leading to sapphire-like mineral snow. It's hard to imagine. A sky glittering with falling metal, silent and heavy, melting before it ever touches the ground. On these worlds, weather is not made of water, but of stone, proof that even the familiar can turn strange under alien suns. Some planetary systems move like choreography, locked in gravitational dances. Their orbits are tuned to each other's rhythm, precise and enduring. In systems like TRAPPIST-1, 7 rocky worlds orbit a small red star, each influencing the next. Their timing is so perfect that they act like gears in a celestial clock, preventing collisions and maintaining harmony for billions of years. They may move this way, locked in step, silent and beautiful. It's a form of balance written in mathematics. A cosmic ballet where every motion keeps the music alive. But not all systems are stable. Some appear calm today but are doomed to fall apart. Over millions or billions of years, gravitational nudges can pull planets out of alignment. They might drift into new orbits, collide, or be ejected entirely. Simulations show that some systems may collapse within 100 million years, their graceful dance ending in chaos. Even the universe's most intricate balances are fragile. What seems eternal can unravel, slowly and quietly, until all that remains is dust and memory. Some of these temperate worlds might resemble Earth in ways both familiar and strange. They could have blue oceans, drifting clouds, and green countenance. Yet their skies might glow a different color, perhaps orange beneath a red sun, or pale gold beneath a cooler one. Their air might smell faintly of ozone or methane, their stars rising slower or faster than ours. Gravity could feel heavier or lighter. The horizon might curve differently. We can't yet see their landscapes, but through science and imagination, we can begin to picture them, quiet coasts beneath alien dawns, waves rolling under soft, unfamiliar light. Some planets may carry life, but not intelligent life, just the slow, patient growth of nature. Microbes, simple plants, or drifting plankton might thrive where oceans and sunlight meet. Even without voices or tools, such life would be profound proof that biology can bloom wherever chemistry allows. On Earth, life took billions of years to evolve from single cells to minds that wonder about the stars. Elsewhere, that story might still be in its earliest chapter, a galaxy full of seedlings, some just beginning to wake, others already ancient and silent. Yet we must also remember, many planets are lifeless, not because they failed, but because conditions never allowed them to begin. Too much heat, too little atmosphere, too much radiation, or simply bad luck can make a world sterile. Even then, those barren worlds are beautiful. A planet doesn't need life to be worthy of awe. Its craters, storms, and shadows are part of the universe's quiet art patterns, written by time, gravity, and chance. A desert planet, a frozen giant, a molten sphere, all of them part of the same grand design. Some worlds might evolve life so differently that we wouldn't recognize it. On Earth, life depends on water and carbon, but in alien seas of methane or ammonia, other chemistries could emerge, living systems built from silicon, sulfur, or metals. They might breathe different gases, move in strange rhythms, or think in ways beyond our imagination. They may not even need cells or DNA, existing instead as patterns of reaction or magnetic fields drifting through fluid skies. Life doesn't have to look like us to exist. It only needs to find a way to endure, to change, and to remember itself. Some planets might already have come and gone. In the long age of the galaxy, entire civilizations could have risen, flourished, and vanished before Earth was even born. Their ruins, if any remain, might now be buried beneath ice or sand, their stars long dimmed. Space keeps its secrets well, but even the faintest whisper, a strange chemical imbalance, a radio echo, or an engineered orbit, might one day tell us that we were never the first to look up and wonder. It's a humbling thought. We might be the newest voices in a chorus that has been singing for billions of years. Every exoplanet discovered expands our understanding of existence. Each one proves that the universe is not empty, but abundant, creative, restless, alive with possibility. Some worlds are violent, others calm. Some old, some newly born. Each turns silently, following its own rhythm around its own star, and together they form a vast symphony of motion. We are only beginning to hear its music. When we gaze at the night sky, we see just a handful of stars with the naked eye. But around nearly every one of those points of light, planets circle unseen. The Milky Way alone may hold more than 100 billion worlds. And beyond that, there are countless other galaxies, each with their own suns, their own orbits, their own unknown skies. If every star holds even one planet, then the number of worlds in the universe is almost beyond comprehension. An infinity of possibilities, waiting in the dark. Perhaps somewhere among them is a world much like ours, a planet with oceans and weather, with clouds and wind and life that listens to the stars. Maybe, right now, someone there is looking back, wondering the same thing, whether they are alone. They orbit quietly, and so do we. Both sides waiting, both sides searching, across the endless dark between dot. Until that day, we keep listening. We build better telescopes, more sensitive instruments, and sharper eyes. We study faint shadows, tiny wobbles, whispers of light. Each data point, each flicker, might be a clue, a glimpse of another home, another beginning. It's slow work, but patient work, done by dreamers who believe that discovery is worth the wait. So, as you drift toward sleep tonight, imagine them, the billions of planets turning in silence, some burning, some frozen, some soft and blue, some hard and grey, each one unique, each one a story written in light. They orbit quietly, waiting to be seen, waiting to be known. And maybe, somewhere out there, a distant voice is whispering the same thing about us. They orbit quietly.